So here we have problem 22. So in deep space, two uniform spheres of masses 24 kilogram, and the second one is 107 kilogram. So they're released from the rest. The distance are given. So you have to find the speed of the sphere with the mass 24 kilogram, with the centers 25 meter apart. Okay. So initially, basically, we had two stars. Okay. This one is M1, which is 24 kilogram. This is M2, 107 kilogram. And the distance at 14 meter apart. Okay. So initially they were at rest. And once they release it, due to the gravitational force, attraction force, they start approaching to each other. So we have to find what will be the final speed of the M1 at a distance of 25 meter. Okay, so how can we do it? So initially, Bohr's initial velocity for two objects is equal to 0. Okay, so in this case we have to use two formulas. One is the conservation of the momentum, second one conservation of the energy. So conservation of momentum is initial momentum is equal to final momentum. Okay, initially both objects was at rest, so therefore initial momentum is 0. The final momentum will be m1 v final 1, since if we take this side, right side, as a positive, so we get m1 v final 1 as a positive, plus second object will move to the left side. So in the momentum is very important to know the direction, because depending on the direction the sign will be different, positive or negative. So in the second object m2, in the bracket, negative of the v final 2, because it's moving to the opposite direction. Okay, so by plugging the masses we can do calculate that v final 2 is equal v final 1 divided by 4.458. Okay, let's keep it here. Now in the second equation we have to use conservation of the energy. So initial energy is equal to the final energy. Initial energy consists from kinetic energy 1 initial, kinetic energy 2 initial, plus potential energy. Final energy will be kinetic energy final 1, kinetic energy final 2, and potential energy final. So since initially objects having 0 velocity, we can equalize them 0. We end up only with initial potential energy, which is equal to the negative gm1 m2 divided by d initial. D initial is 40 meter. Okay, then for the final one, what we have m1 v final 1 squared, m2 v final 2 squared, and negative, because potential energy is always negative. Okay, gm1 m2 divided by d final. D final is basically 25 meters. So basically, I take this one, I brought it to the left side, and then I also take the two 2's and multiply it here, and then changing potential energy becomes this number, and then I plug the masses. For the final V2, I took it from here, I plug it here. Okay, so then I did calculation and I got the speed final for the mass 1, and that becomes this one.